Okay, hello, good morning. My name is Jeroen Schokker. I'm from TNO Geological Survey of the Netherlands, and also on behalf of my co-author from BGS and GEOS, I'd like to present to you the concept of GeoCity information modeling and the importance of man-made grounds when working in the urban environment. As we have seen already in a lot of presentations and throughout post-suburban, modern cities are vibrant places, and this dynamic character does not only takes place above ground, but certainly also below the surface. The urban subsurface is a combination of the natural characteristics and human alterations and additions to this natural environment. And we have seen quite some examples where the resilience of a city and also sustainable development can clearly benefit if the challenges and opportunities of the subsurface are taken into account. Within Working Group 2 of Post-Suburban, we have identified a lot of good practices on how to collect and use information on the subsurface. This concerns both the collection and storage of data, but also the construction and update of 3D models, both geological models and applied models. And we have worked on how to build sustainable relationships between cities and researchers. So we, I think, mainly concentrated on, well, basically all the steps from 2 onwards, but mainly on 3 and 4 maybe. And as, for example, Helen pointed out yesterday, this might not be enough. The technical part is not enough to influence decisions, so that clearly needs to be taken another step. We also identified some key knowledge gaps, and one of the key knowledge gaps clearly is a lack of integrated modeling, the integrated collection and presentation of subsurface and above ground information, because integration we see in terms of connecting above and below surface, and maybe also once collected, using information in the various steps of the urban planning process. Because to inform strategic decisions on urban planning, a lot of data might be necessary and is around somewhere, but it's often viewed in isolation. So it's necessary to combine this into a holistic above and below ground view we see. And one of the things that's key when working in the urban environment is also taking into account the anthropogenic subsurface layer in its entirety. But I'll come back to that. So we developed a sort of concept which we call GeoCity information modeling, which is really a process involving the generation, the sharing, the integration, and also the management of all sorts of digital representations of both the physical and functional characteristics of at least 3 different layers of the urban environment. The surface layer, which consists of both the natural and man-made on-surface features, then the anthropogenic subsurface layer, containing man-made ground, but also buried infrastructure, foundations, etc. And then the natural subsurface layer, consisting of the geological units and their properties, and maybe also the associated processes and hazards. So, as also Susie already pointed out, there are some concepts and workflows around already, like building information modeling and city information modeling. But we feel we can add something to those. We certainly do not want to replace them or anything like that. But we feel that with the concept of GeoCity information modeling, we extend downwards to also include the anthropogenic subsurface layer in its entirety and also the natural subsurface layer. And we feel that this concept has most added value at the scale in between the building site and citywide urban planning. So I already touched a little bit on the life cycle of information. So when we are in the early phases of planning, or for example, a part of a city, we start making an inventory, we then do programming or strategic planning, we design, we construct, we maintain, and after that, well, things might be demolished and rebuilt again, or anyhow, the whole cycle can start over again. And it would be so good if the information gathering in one phase could be used, that information could be used in those other phases as well. So for this process we need, well, I call it here model, but you could also say, well, just information, 3D or 4D digital representations, which can be exchanged or networked to support those volumetric decision-making decisions about the urban space. So it's very important that we talk in and think in 3D or 4D here. So these models, they must be able to handle the different scales and update needs in the different layers. They should have a flexible output scale, a flexible output format, depending on the user and the usage. It's very important to stress here that we do not mean to bring all this information together in one super model or something like that. That's certainly not what we mean. It's very important that all these specialist data models, they may exist with their owners in specific tools. What's key here is the communication of information. Communication in the right form to all these specific users in the specific and different phases of the planning process. So, with this vision in mind, those GeoCIMs could be used by a wide range of people in a wide range of for a wide range of purposes. And we think the biggest impact of using this process is at the beginning of a planning process. But in all of these planning phases, it might add something to what we have now. As Susie already pointed out, at current we don't see any good examples of integrated models yet. There are some, well, you could say best efforts, like in Glasgow, like in Odense. We saw a very nice example from Oslo yesterday as well. We are doing some things in Rotterdam, trying to connect surface and below ground, but the ultimate model is just not around. Now I'd like to highlight or go into some more detail on some of the important issues when working on an integrated model in this way. First thing to start with is input data. Of course, ideally, the data you use completely depends on the modeling purpose and the modeling scale. But in practice, of course, it's dependent on what's available within the project means and also what your modeling method can handle. Very important here is the use of data exchange, common data exchange formats. For example, within the context of the ASK network, that's one of the issues that has been stressed. And we see a large benefit for using nationwide publicly available data sets, like for example the key register data sets in the Netherlands, which extend both above surface and below ground. This helps this kind of process. Then the importance of the anthropogenic subsurface layer. It's really the linking pin between the above and below ground worlds. But if it has this function, it needs to be all-inclusive. It should encompass really everything that's present between the surface and the natural subsurface. And that is of influence to the model properties at the intended scale views. So that should be reworked natural deposits, artificial deposits, foundations and basements, subsurface infrastructure, but also things like archaeological heritage, for example. If you approach urban modeling in this way, you should think about scale, because obviously there's much more information available and probably also needed at surface level than at 10 or 20 or 50 meters below surface. So, for example, if you have various model layers or sub-models, an above ground, an anthropogenic subsurface and a natural subsurface layer or model types might differ. For example, you might have a surface BIM model, you might have a stochastic anthropogenic subsurface model, or you might have a deterministic or layer-based natural subsurface model. And almost naturally, the resolutions of these models, both in the horizontal and the vertical direction, they will not be the same. So you might be talking about a sort of nested modeling, like a pyramid. And then the point of maintenance and update. This kind of modeling process is all about making effective and efficient use of data and information that is there, but needs to be there at the right time in the planning process in the right form. We feel that the technical solutions for efficient model maintenance and update are there. I have seen them, for example, in the Odense modeling, and when I visited IGIS a couple of weeks ago with cloud solutions, for example, where all users can access the data, even in different forms if they would like to. So that's not really, the technical point is not really the problem here. I think it's very important that all parties involved have to acknowledge the need to keep models up to date, to preserve their value, and all the effort that has been put into making all this information available. And this requires sustainable funding and also a feedback loop to report back model data and information issues. And that's something we at TNO are currently struggling with, because if our models become part of a key register, we have to be sure that we can adapt to all the issues that are being reported by our users. So this asks for strategic engagements between cities and researchers or companies or institutes. And such a strategic engagement, like for example building up a network like us, is also important for the initiation of a GEOCIM process, for example, in another part of the city, and also the use of the information across planning stage boundaries. So to conclude, I think, and I don't think I'm the only one, that there is a clear need for the integrated above and below ground modeling throughout the planning process. So it's really time for something like GEOCIM. The anthropogenic subsurface layer here is key, the linking pin between the above and below ground domains, and the key for a successful and applicable model result. But another key, maintenance and update, which asks for strategic engagements between the cities and the people that know and collect the data and information that are there. Okay. That's my presentation. Thank you.
Thank you, Jeroen. Any questions?
My question is, if you are going to make recommendations,
Yes.
which scale you are going to recommend to start with?
Well, as I said, and as you certainly know, that completely depends on the purpose. But if you start at the beginning, at the strategic planning level, information doesn't need to be at the highest level of detail. But that can of course change in the course of this planning cycle. What's important is that information is available in the right format and in the right scale in that specific part of the planning process where you're in. And there, these common data exchange formats, publicly available data sets, they might help to collect that information at the right time when it's necessary to have it. So I think scale is important, but sometimes you also just have to work with what's available at the time when you're there.
One question more?
Yeah, well, thank you, Jeroen. I think it's an excellent presentation. It's a really interesting thinking gone into that. I'm querying the reference to the linking anthropogenic layer. I would tend to equate that with made ground, worked ground, and so on. But is it actually a broader thing than that? Is it really the zone of interaction within the subsurface? Does it really also include, for example, the tunneling infrastructure and the mining infrastructure that's been left behind? Is it actually a broader thing than just the anthropogenic layer?
Yeah, I think you are right. Maybe my term, the terms I used are not exactly correct here, but you should certainly include, I feel, tunneling and mining and those kind of things. We'd like to include all the man-made alterations and additions to the natural subsurface in this zone. And if you don't take them into account, your model result won't be realistic, we feel. So.
Can I just add? Follow up, if I could add, sorry to dominate. The diagram you showed of the workflow for GEOCIM, there were 5 elements in it, and you referred to the demolition phase. I think that's a really important thing to add to that diagram, because it was emphasised even in the earliest WG1 reports that the subsurface retains a history of former use. And of course, when you demolish buildings, you never take the piles out of the ground, you don't remove all of the elements of the basement. It's actually really more important to us than it is to people who see the world as a surface phenomenon, that we include that additional step, the demolition phase, because you can't remove all vestiges of the construction.
No, that's an important addition. I think you're quite right. Thank you for that.
The problem is to get the information.
No, that's a challenge. That's no problem.
Yeah. Johan?
I don't know if it's beyond our discussions, but I'm somewhat concerned with the plan itself, connected to what you've said. I totally agree as far as I understand what you're presenting. I totally agree, and I welcome the use of 3D modeling for analysis and planning throughout the process as you described it. But the product itself, Jeroen touched that yesterday. I have some concerns with how the politicians communicate when if the plan itself would be in a 3D format. And
no.
The storage of it and maintenance and management of a formal plan in our legislation, it's nothing that prevents us from even having a plan in 3D, but I can't see how it will be stored and managed. And I have.
Now that's an important addition. I forgot to mention that, but well, the output format of this information, of course, does not necessarily need to be 3D or 4D. It might be downgraded towards a 2D map, if that's the preferred output format for communication to planners or decision makers or whatever. So that's that's certainly, we certainly do not want to advocate to only use information in 3D or something.
As I suggested, maybe it's beyond our discussions here, but as a tool,
Mhm.
thank you as a planner, we want it.
Okay, thank you.